Alright, so I got the sprockets in. So you can see here, here's my 4 new sprockets. And here's the that sprocket you've seen on the motor shaft probably a few times by now. This is actually an ANSI number 40 sprocket. So that's why you're probably wondering why I didn't just use this sprocket. It's because it was an ANSI number 40 sprocket. So it doesn't really fit the chain. It's close, but it doesn't quite fit the chain. So I tested out one of these new sprockets and it fits the chain absolutely perfectly. So that's exactly what I was looking to do. So as you can see here, these are both 15 tooth sprockets, and if I lay them on top of one another, you might be able to see if I line up the tooth on the left there. Let's see, it's probably pretty hard to tell. There we go. Yeah, you might be able to see that as I go around here, the teeth don't quite line up anymore. It's kind of hard to tell because I don't think I can really line up these sprockets right now. But basically, the tooth pitch on both these sprockets is the same. So the distance between the center of each tooth is the same. But the actual roller area is different. The ANSI number 40 sprocket, the roller is smaller, I believe. I could be wrong on that. It might be larger. I'm going to have to double check my numbers. But in any case, what actually happens is the chain, whereas on this sprocket it sits perfectly, on this sprocket the chain sits a little bit too low, I think. So as it goes around the sprocket, it starts to bind as the discrepancy builds up as you go around the sprocket. So yeah, that's why I didn't want to use this sprocket anymore. It's just because it's just not quite the right sprocket for the chain. So I got these sprockets, and yeah, so these are a metric British standard sprocket, and they fit the chain perfectly, but they're not quite the exact keyway and shaft size for the motor. This sprocket here has a 7/8 inch hole in it with a 3/16 inch keyway, whereas these sprockets have a 22 millimeter bore with a 6 millimeter keyway. So you convert this to metric and it is 22.2 millimeters, and this is 22 millimeters. So I think to get this to fit on, I'm just going to have to lightly polish the inside of the sprocket. It's so close it might just fit on as it is, but I might have to polish it. We'll see. And the keyway, whereas it fits perfectly on this sprocket, as you can see like that, it's not, this sprocket, this keyway is a little bit larger. It's about 1 millimeter larger. So I might have to make a little shim there for it. But it's really close, so I think if I just make a little shim, it'll be just fine. So yeah, hopefully I'll put those on the bike in a little bit. So I got a 13 tooth, a 15 tooth, a 17 tooth, and a 19 tooth. So I got 4 different sprockets that I can toss on there for different ratios. And here's kind of how I went about figuring out these sprockets. I took there's a lot of different specifications for the motor, but the best specification I could find was this, that spins at 3050 RPM at 72 volts. So I just used that nominal RPM value and for the motor, and then I took my tire dimension. It's actually an 18-inch tire on my bike. It's actually a little bit strange. I think most bikes these days are 17s front and rear, but mine is an 18 on the rear, and actually it has a 17 on the front. So I plugged those numbers into a tire calculator, and I got a diameter of 25.09 inches. Convert that to metric, because standard is basically useless to me, and I get a wheel circumference of 2 meters. So and then I took a nominal value of 100 kilometers per hour, and I determined that in order to do 100 kilometers per hour, the tire needs to be spinning at 833.33 RPM. And I determined that from the motor RPM to the wheel RPM, I need a reduction of 3.66. And so from that, I basically determine the different reductions here from the, I have a 55 tooth sprocket in the rear, and just using a bunch of sample front sprockets, I calculated all the reductions, and one here just so happens to be 100 kilometers per hour, the 15 tooth sprocket. So I ended up ordering a range just to be sure, because you know this is at a nominal 72 volts. Who knows, the battery pack might be lower than that, might be higher than that, so I figured I'd get a range of sprockets in this area. So I ended up getting the 13 all the way through to the 19 tooth sprockets, so I can pretty much choose a top speed of anywhere between 90 and 130 kilometers per hour. So I think for today I'm going to throw on the 15 tooth for now, see how that does, and then if I want to go faster or I want more torque or whatever, I can always swap out the sprocket. So I think I'm going to give that one a go for now. On another note, I think the weather forecast for tomorrow is +4, so I think a couple of my buddies are going to be coming over, and we're going to be giving the bike its first spin tomorrow, so yeah, stay tuned for that.